Welcome, class, to Lesson 8-2. Today, strong mathematicians can draw and measure angles. So, take out your notebook, your pencil, write down today's date, the name of the lesson. If you have a protractor, that would be great. If not, hopefully I've attached a protractor link that you can have one available for you to use to help you with measuring angles today. And with that, let's begin. The good news is, box one, you see a lot of review terms. There'll be some more terms we're going to add today, but we know what a point is right now. We have a line and the symbols of how it can be written as well. We have line segments, which we know are part of a line. They have endpoints. Also, an angle, something we added today is this section right here. So you're going to add this down to your notes right here about angles. Angles are measured in units called degrees. And we kind of mentioned that yesterday. 1 degree is the measure of one very small turn from one ray to the next. And that's probably even bigger than a degree, but it kind of gives you an idea of this. A degree is a very small unit of measurement. If you have a protractor, you look for one tick to the next tick. That's actually how small a degree is. So this one's probably not a degree to scale. But you want to write down this one, so you can pause the video on what is a degree. It's a unit of measurement and how we measure angles to help you out. Another thing we want to add right here, we talked about a right angle already, but we want to add this one to our notes, a straight angle, which seems kind of weird that you have a straight angle, but a straight angle measures 180 degrees, like a straight line. Said a 180 degree turn traces 1/2, not half, so I'll edit that right there, 1/2 of a circle. So that's how big a straight angle is. It's 180 degrees, it's half a circle. So a line, if we start on one point, go all the way to the other, we have a 180 degree angle or a half a circle. So you can pause down, write that one to add that to your list. We have an acute angle and an obtuse angle, so we're good to go with those. And now we have a protractor. So this is the tool that hopefully you have found, or you can pause the video right now and run around so you can find one or print one off the internet to help you out. And this is the tool that's used to measure angles. I'm going to show you how to use this tool and to operate this tool to help you out solving the measurement of angles. So you pause down, write down protractor, go find one if you got one, and we shall continue. So now first off, identify and measure each angle on your protractor. The first part I always say is identify the angle first. This is going to help you with the measurement because protractors have different operations. So look at an angle PAM. I see that it is less than 90, right? So I think in my head I have this little dot. There's my 90 right there. It doesn't go and touch the 90 degree line, so I know that this is an acute angle. So now that I know what acute, what tells me is that the number should be between 0 and 90. That helps me because now when I pull out my tool of the compass, I can slide it over. And now you notice I'm going to put this part right here on the vertex, and I'm going to match it up with a line. So if I can go back to my... So notice you see that how right here on the... I have it right connected to this line, which shoots right at the 0. And then I have the other line, which shoots right there. And now all I can do is I got to start where the 0 is. Notice how there's two things, so I can measure either direction. So I'm using the inside area. I'm going to 0, and this looks like it is a 50 degree angle. So by doing that and adjusting that, you can see exactly it's 50 degree. We might say it's 51, but obviously if we get really technical, but it looks like I'm trying to think the bigger picture, this is probably most likely a 50 degree angle. We can take our same thing now, look at our bottom angle, our strategy again. We draw a little line right here that kind of represents 90. We know that our line is bigger than 90, so that means it can't be an acute. It has to be obtuse, which means we know the number has to be between 90 and 180. So notice there's two measurements. There's a measurement on the outside and there's a measurement on the inside as well. So there's two different angles depending on where you start. So if you start over here, you're going to follow the outside. If you start over here, you're going to follow the inside to get your measurement. Otherwise, your measurements would be inaccurate. That's why I always say if you identify it first, it makes it a little easier to figure out the angle of measurement. So I angle it right there. My line starts right here is the 0, which means I'm going to go this way with the 0. So I'm following this inside track all the way over to 150. And I know 150 is between 90 and 180, so I know my measurement is accurate. So you can pause the video right now and just kind of get an idea of what these angles are and how to use a protractor. Maybe I don't know if you can hold it up to the screen and see if you can, or mine are, you're getting the same measurements that I'm getting. And right now we're taking our skill and knowledge and we're going to apply it to a picture or a drawing. So right now it says name one right angle. We think, what do we know about right angles? Well, right angles are 90 degrees. All right, so if I look at this drawing right here, where do I see 90 degrees? Well, I see this little square right here that tells me this is a 90-degree measurement. So I can have angle, I need the symbol to tell me that one, and SEC. Is there another one? There is another one. Do you think you could find and write that one down too? That'd be great. Notice name one straight angle. So we're going to find the straight angle. What do we know about straight angles? Well, we know that they're 180 degrees. So I'm looking right now, and I have an angle of TES, which would work because we have a vertex, that one. Are there any other straight angles? Good question. So the question right now is how much greater is the measure of an SET than the measure of angle CES? Well, if we look at these angles right now, well, SET is, so it's from here, here, here. Well, that would be 180 degrees. And looking for how much greater, so we figure that one out. And then the angle CES, so we find CES. Well, it looks like it has this part right there, so it'd be 90 degrees. So we would subtract it how much greater? It would be an answer of 90 degrees. And now we have the measure of SEW. So I'm going to get my eraser right here. I'm going to erase some of this information so we can kind of get a clean look again as we got lots of lines going on. So SEW is 135 degrees. So if I go right here, here's S, here's E, and here's W. So this one is 35 degrees. It says, what is the measure of CEW? So that would be this one right here, CEW. Well, unless I had a protractor out, I don't have that. But what is the measure of WET? All right, well, let's figure this out. So then they also want me to figure out the other one, but we'll stop with the first one right now. What is the measure of SEW? Well, if we know that from here to here is 135, and we know from here to here is 90, well, to figure out the rest of the difference, all we would really have to do then is subtract. So 135 minus 90 equals 5 here and a 4, so this would be 45 degrees. Oh, so SEW is 45 degrees. And now what is the measure of WET? So we see where WET is, would be, I'm using the infamous yellow that I despise. There it is right there. Well, what do we know? Well, if this is 90, 45, well, we know that a straight angle, so if I go back and I continue my straight angle, if I go from here all the way to here, this would be 180. And we know from this inner one that we're already 135. We can just subtract 180 minus 135, because that's already part of that angle, and get an answer of 45. So WT is also 45 degrees. So notice by noticing right angles and by noticing straight angles, that can help us find angles of other parts that are within a drawing, because we know that a straight angle is always 180 and a right angle is always 90. So you can pause the video right now, write down this information to help you out. Even sketch the drawing loosely to just give you an idea of how to take this information and how to use it. And now just some things. Can we identify two streets that make an acute angle? There are a lot of things going on in this picture. So our goal is just kind of be like, can we just find different angles right now? Can we find two streets that make an acute angle? So think about what acute is. And we know acute's less than 90 degrees. So my guess is, let's see if you can find some that I'm going to circle. I see Avenue A and Avenue C meet right there. That would be an acute angle. And where else might there be an acute angle? Ooh, it looks like, how about where Avenue A and Jefferson meet? Right here looks like there's another acute angle. So those would be two acute angles. We got those checked off. What about two obtuse angles? Can you find some obtuse angles on here? I'm going to go with, let's see, obtuse angle of where Avenue A and Washington meet. That's a big obtuse angle. And another obtuse angle, well, I'm going to go with this one. Avenue C and Avenue B on this side make an obtuse angle. So notice you think about that, if avenue B is a straight angle, one side is acute, the other side would be obtuse, which would make sense. And last but not least, can you identify two streets that make right angles? Well, there are tons of right angle streets. We can pick a whole bunch of them. Let's see if you can guess the two I'm going to guess. I'm going to go with 2nd and Jefferson. And I'm going to go with Lincoln and 4th Street. There we got some more two right angles or perpendicular lines. And with that, you can kind of just get an idea of where some more acute and obtuse and right angles in real life where you would see these. You can draw a line right now and label it box 3. Now your turn. Today I want you not only to draw, I want you to draw and measure an acute angle labeled TAN. So I want you to draw one, label it. Make sure when you're drawing, use your straight edge to make them nice and straight. Lines are easier to measure. And then you can draw and measure a right angle labeled LOW. And then I want you to draw and measure an obtuse angle labeled SUN. So that's why it's good practice drawing, not only drawing angles today, but also now drawing and measuring angles of our next skill. And here's a picture drawing, some questions for you to answer now. Can you name one right angle? Can you name a straight angle? How much greater is angle car versus angle bar? And the measure of cap is 150. What's the measure of BAP? And what's the measure of par? So you can pause the video right now and draw that picture out, answer these questions, and I look forward to seeing your work. If you have any questions, comments, or concerns, feel free to write them down or share them out. If you have any strategies that you use, let us know. And thanks again for another great lesson.